Hi, welcome to this Corbettmaths video. In this video we're going to look at the video solutions to the Corbettmaths Practice Questions on finding the surface area of a cylinder. If you need any extra help in finding the surface area of a cylinder, if you go to Corbettmaths and go to the videos and worksheet section and scroll down to video number 315, there's a dedicated video tutorial there on finding the surface area of a cylinder. Alternatively, you can scan this QR code. But in this video we're going to focus on the video solutions to the practice questions, so let's get started. Okay, let's have a look at our first question, question number 1. So question number 1 says, shown below is a cylinder with a radius of 2 centimeters and a height of 5 centimeters, and we've been asked to calculate the surface area of the cylinder. Okay, so if we want to find the surface area of a cylinder, we need to get the area of the circle at the top of the cylinder, the area of the circle at the base of the cylinder, and the area of the curved face, so that curved face that goes around the outside of the cylinder. And to do that, well, the area of a circle is pi r squared, so that's quite straightforward for the area of the circle at the top. The area of the circle at the bottom is going to be the same as the area of the circle at the top, so that's straightforward as well. And in terms of that curved face, what we're going to do is, if you have this curved face, if you were to cut it vertically and roll it out, you would have a rectangle. The length of the rectangle would be the circumference of the circle, and the width of the rectangle would be the height of the cylinder. So if we do the circumference of the circle times the height of the cylinder, that'll give you the area of that curved face. And then you can just add it together with the area of the circle at the top of the cylinder and the bottom of the cylinder, and that'll give you the total surface area of the cylinder. You could also use the formula as well, and I'll talk about that after I use the first approach. Okay, so in terms of finding the area of the circle at the top of the cylinder, that's quite straightforward. So the area of the circle is going to be pi r squared. So we're going to do pi times the radius of the circle, which here is 2 centimeters squared. And if we do pi times 2 squared on our calculator, that gives us an answer of 4 pi. And you could leave it like that, 4 pi, and just keep it as 4 pi if you wanted to. Or as a decimal number, that's equal to 12.56637 and so on centimeters squared. So that's the area of the circle at the top of the cylinder. And I said you could just leave it as 4 pi because you're going to be adding it to some other stuff later on. And then if you need to give your answer as a decimal then you can round it and so on. Okay, so that's the area of the circle at the top, and it's also the area of the circle at the bottom. So in terms of the surface area of the cylinder, we're going to do 12.56637 and so on, plus 12.56637 and so on, or you could do 4 pi plus 4 pi. Okay, so that's the area of the top and the area of the bottom. Now we want to find the area of that curved face. So the area of that curved face will be the circumference of the circle times the height of the cylinder. Because remember, that's a rectangle if you roll it out, and the length of the rectangle will be the circumference of the circle, and the height of the cylinder is the width of the rectangle. And then if you times them together, that gives you the area of that curved face. So let's find the circumference of the circle. The circumference is pi times diameter. So if we do pi times the diameter of the circle, which the diameter of the circle will be 4, because if the radius is 2, the diameter would be 4. And if we do pi times 4, that's equal to 4 pi. So that means the circumference of the circle is 4 pi. So to get the area of that curved face, the area of the curved face would be equal to, it's a rectangle, the circumference times the height of the cylinder. So we're going to do 4 pi multiplied by 5. And 4 pi times 5 is equal to 20 pi. So that's 20 pi, or as a decimal number, 20 pi is equal to 62.8318 and so on centimeters squared. So we've now found the area of the top of the cylinder, which is 12.56637 and so on centimeters squared. We've got the area of the base of the cylinder, which is 12.56637 and so on centimeters squared. And the area of the curved face of the cylinder, which is 62.8318 and so on centimeters squared. And then if we add them all together, so if we add 62.83185307 and so on, if we add them all up, that'll give us the total surface area of the cylinder. We get an answer of 87.9645943 centimeters squared. So that's the total surface area of the cylinder, 87.965 centimeters squared to 3 decimal places, to 3 dp. And that's it. Just to explain there, you could also, instead of using the decimal numbers, you could have said, well, the area of the top of the cylinder was 4 pi, the area of the base of the cylinder was 4 pi, and the curved surface was 20 pi, and you could add up the 20 pi, the 4 pi, and the 4 pi, and you get 28 pi. And then if you change 28 pi to a decimal number in your calculator, you get 87.9645 and so on. And that's it. So that's how you find the surface area of a cylinder. You find the area of the top, which is the area of the circle, the area of the bottom, which is the area of the circle as well, the same area, and then the area of that curved face, which is the circumference of the circle times the height of the cylinder, and that gives you the area of that curved face. And then just add them all up. Okay, so that's one approach. Now I'm just going to rub out this working out for a second, and I'm just going to show you another approach. Another approach is to use a formula, and that's the surface area of a cylinder is equal to 2 pi r squared, so that's the area of the two circles, plus 2 pi rh, where 2 pi r is the circumference of the circle and h is the height of the cylinder. So this is actually what we've just done, but as a formula, where 2 pi r squared is the area of two circles, and 2 pi rh would be the circumference of the circle times the height of the cylinder, which would give you the area of that curved face. And just remember that 2 pi r is the same as pi times diameter, because the diameter is double the radius. That's why it's 2r there, double the radius times pi times the height of the cylinder, and that'll give you the area of that curved face. And that's it. So if we were to use the formula, we would just substitute in the values for r, the radius of the cylinder, and h, the height of the cylinder. So that'll be equal to 2 times pi times the radius, which is 2 squared, plus, and then 2 times pi times the radius of the circle, which is 2, times the height of the cylinder, which is 5. And then if we type this into our calculator, we get that's equal to 28 pi. And then if we change 28 pi into a decimal number, we get that's equal to 87.96459943 centimeters squared. And again, that's the same answer that we had earlier, which is 87.965 to 3 decimal places. And that's it. So that's the surface area of that cylinder, 87.965 to 3 decimal places. So you could, if you wanted to, learn the formula that the surface area of a cylinder is 2 pi r squared plus 2 pi rh. I personally just do it individually, where I find the area of the circle, I then know the area of the other circles the same, I find the area of the curved face, and then just add them all up. Okay, let's look at our next question, question number 2. So question number 2, we've got another cylinder, and this time we've got the diameter of the cylinder is equal to 12 centimeters, and we've got the height of the cylinder is equal to 7 centimeters, and we've been asked to work out the curved surface area. So this time we've not been asked for the total surface area, just the curved surface area. So we just want to find the area of that curved surface, that curved face going around the outside of that cylinder. So to find the area of that curved face, we just need to do the circumference of the circle times the height of the cylinder. So the circumference of a circle is pi times diameter. So it's going to be pi times the diameter of the circle, which is 12. And if we do 12 times pi, we get 12 pi, or as a decimal number, that's equal to 37.699111184 centimeters. So that's fantastic. We've now found the circumference of the circle. We've found the circumference of the circle. So the circumference of the circle is equal to 37.699111184 centimeters. Now, if we want to find the area of that curved face, remember, if we cut it vertically and roll it out as a rectangle, where the length of the rectangle is the circumference, and then we just need to times it by the width of the rectangle, which would be 7. So we just need to do 37.699111184 and times that by 7. Or you could just do 12 pi times 7. Some people just like using it in terms of pi and then changing it to a decimal number at the end. So if we just times by 7 on our calculator, we get an answer of 84 pi, or 263.8937829. So that's there, and that would be in centimeters squared, because obviously we're dealing with centimeters here, and it's an area. So that means to 1 decimal place, the area of that curved surface, the area of that curved face, would be 263.9 centimeters squared. And that's it. Okay, let's look at our next question, question number 3. So question number 3, it's a bit of a tongue twister in terms of saying it. I've struggled saying this sentence quite a few times here. A cylindrical container is used to store crisps, and the radius of the container is 3.8 centimeters, and the height of the container is 23 centimeters. And the question says, calculate the surface area of the containers. So we want to find the surface area of this container. So to do that, one approach is to use the formula. I'll do that at the end. And the other approach is to find the area of the circle on the top, the area of the circle at the base, and the area of the curved face. So let's do that. So in terms of the area of the circle on the top, that's going to be the area of the circle is going to be pi r squared. So we're going to do pi times the radius, which is 3.8 squared. And when we do pi times 3.8 squared on our calculator, we get that's equal to 45.36459792 centimeters squared. So that's the area of the circle at the top of the cylinder. It would also be equal to the area of the circle at the base of the cylinder. So let's write that down. So we've got 45.36459792. Notice here I'm not rounding yet because we're going to be adding up, and I like to just round at the very end. And then another 45.36459792. So that's the area of the two circles. Now let's find the area of the curved face. So that's going to be the circumference of the circle times the height of the cylinder. So the circumference of the circle. So to find the circumference of the circle, circumference is pi times diameter. So we're going to do pi times the diameter of the circle. Now the radius is 3.8. The other radius on the other side would be 3.8. So if we add them together, 3.8 plus 3.8 is 7.6 centimeters. That would be the diameter of the cylinder. Or you could just double 3.8, which is 7.6 centimeters. So that's going to be pi times 7.6. And if we do that on a calculator, pi times 7.6, that's equal to 23.87610.417. So that's the circumference of the circle. But to find the area of that curved face, we then need to times it by the height of the cylinder, because remember, that would be a rectangle. If you cut it vertically and ruled it out, it would be a rectangle. The length of the rectangle would be the circumference of the circle, and the width of the rectangle would be the height of the cylinder. So we're going to do 23.87610.417, the circumference of the circle, times the height of the cylinder, the 23, and that's equal to 549.1503.958. So that would be the area of that curved face. So now if we add it together with the area of the circle and the other circle, then that would be the total surface area. So we're going to add 549.1503.958. And when we add those up, let's see what we get. And when we add them up, we get an answer of 639.8795917. Now, the question didn't ask us to round it to any particular number of decimal places. I'm going to round it to 2. So I'm going to give my answer as 639.88 centimeters squared. And that's the surface area of that container. And that's it. Okay, so that was one approach. Another approach is to use the formula. So remember the formula for the surface area of a cylinder. And if you like using the formula, that's fine. The surface area would be 2 pi r squared, the area of the two circles, plus 2 pi RH. That's the circumference of the circle times h, the height of the cylinder, and that would give the area of the curved face. Sometimes this formula might be written the other way around, but it doesn't matter which way you add these, you still get the same answer. Okay, so let's substitute in the values for r and h. So the surface area would be equal to 2 times pi times the radius of the base, which is equal to 3.8, so that would be 3.8 squared, plus then 2 times pi times the radius, which is 3.8, times the height of the cylinder, which is 23. And then if we work that out, let's see what we get. And that's equal to 639.8795917 centimeters squared. And that's the same as what we got whenever we done it by finding the area of the circles and the area of the curved face and add them all up. And that's it. Okay, let's look at our next question. Okay, question number 4. Question number 4 is a non-calculator question, so I'm just putting down my calculator. And we've been told shown below is a cylinder, and we've been asked to work out the surface area of the cylinder and to give our answer in terms of pi. Okay, so I'm going to find the area of the circle on the top, the area of the circle beneath, and then the area of the curved face, and then add them all up. So the area of the circle on the top, the area of a circle is pi r squared. So we're going to do pi times the radius, which is 4 squared. And pi times 4 squared is 16, times pi would be 16 pi centimeters squared. So that's the area of the circle on the top, and it's also the area of the circle at the bottom. So that's going to be 16 pi plus 16 pi, and then we need to find the area of the curved surface of the cylinder. So to do that, we get the circumference of the circle and then times it by the height of the cylinder. So the circumference equals pi times the diameter. The diameter of the circle would be 8. The whole way across would be 8 because 4 plus 4 is 8. So we're going to do pi times 8. So that means the circumference of the circle will be 8 pi. So that means that this distance is 8 pi. Then we're going to times that by 10, the height of the cylinder, to get the area of that curved face. So we're going to do 8 pi times 10, which is equal to 80 pi. So that means that the area of this curved face is 80 pi. So that's fantastic. We've now found the area of the circle on the top, the area of the circle beneath, and the area of that curved face. And if we add them all up, we get the total surface area of that cylinder in terms of pi. So 16 plus 16 is 32, plus 80 is equal to 112. So that's 112 pi centimeters squared. And that's it. Now, if you wanted to, again, you could use the formula and you get the same answer of 112 pi. Okay, let's look at our next question, question number 5. So question number 5 says, shown below is a cylinder. So we've got the cylinder, and we've been asked to work out the surface area of the cylinder and to give our answer in terms of pi. Okay, so to do that, we need to get the area of the circle on the top, the area of the circle beneath, and the area of the curved face, and then add them all up. Okay, so let's start off with the top. So the area of the circle on the top will be pi r squared. So we're going to do pi times the radius of the circle. So if the diameter of the circle is 20, the radius will be 10. So we're going to do pi times 10 squared. 10 squared is 100, and then we're going to times by pi, so it'll be 100 pi. So that means the area of the circle on the top is 100 pi, because 10 squared is 100 times pi would be 100 pi. So that means we've got 100 pi for the top, and we're going to add 100 pi for the base, and then we're going to add the area of the curved face. And the area of the curved face, well, let's consider that. We've got the circumference of the circle, and then we're going to times it by the height of the cylinder. So the circumference of the circle, circumference is pi times diameter. So we're going to do pi times the diameter of the circle. Now the whole way across the circle is 20. So we're going to do pi times 20. And pi times 20 is equal to 20 pi. So the circumference of the circle is 20 pi. We then times that by the height of the cylinder. So 20 pi times 12. So 20 times 12 is 240. And then we've got pi, so that's 240 pi. So that means that the area of that curved face would be 240 pi centimeters squared. So that's fantastic. We've now got the area of the circle on the top, the area of the circle on the base, the area of the curved face, and then if we add them all up, that'll be equal to 440 pi centimeters squared. So that's the area of that cylinder in terms of pi, 440 pi centimeters squared, and that's it. Okay, let's look at our next question. Question number 6. Question number 6 says a can of baked beans will have a paper label wrapped around the outside. So this can of baked beans is going to have a paper label wrapped around the outside. The can has a height of 11 centimeters, a radius of 3.5 centimeters, and the label will cover the entire height of the can. So it's going to be the whole height of the can, and there's going to be a 1 centimeter overlap vertically, so it can be stuck together. So in terms of that curved face, it's going to have an extra length of 1 more centimeter. So remember, for that rectangle, whenever you cut it vertically and roll it out, it's normally the circumference times the height. But it's got an extra 1 centimeter. So it's not just going to be the circumference this time, it's going to be the circumference plus an extra centimeter in terms of the length of that rectangle whenever you roll out that label. Okay, so we've been asked to find the area of the label. So this time we haven't been asked to find the total surface area, just the area of the label. So we just need to focus on this curved face. Okay, so let's consider that curved face. So normally if you've got that curved face, if you cut it vertically and roll it out, you would then get a rectangle. So, and this would be the circumference of the circle. So the length of the rectangle would be the circumference of the circle, and the width of the rectangle would be the height of the cylinder. So that's going to be 11 centimeters. And we know it's 11 centimeters because it says the label is going to cover the entire height of the can. So it's just 11 centimeters in terms of the height of the rectangle. But let's consider the length of the rectangle, because normally the length of the rectangle will be the circumference of the circle. But with this label, there's an extra 1 centimeter. So this label has an extra 1 centimeter so that it can stick on to the other side, and then it would fit around, because if it was just the right size, then it couldn't be stuck to itself. So what we're going to do here is we're going to find the circumference of the circle, and then we're going to add 1, and that would give us the length of that rectangle, the length of the label. So let's do that. So let's do pi times the diameter. So the diameter of the circle, well, the radius is 3.5, so if we double that, it's 7. So pi times 7 will be the circumference of the circle. And if we do pi times 7, that's 7 pi, or, so times by pi, 7 pi, or 21.99114858. So that would be the circumference of the circle. But we're told that this paper label actually has an extra centimeter. There's an extra 1 centimeter overlap vertically, so it can be stuck together. So it's not just 21.99 and so on. We're going to add 1 to that. So that means the length of this rectangle for the paper will be 22.99114858, because obviously it's got an extra centimeter. There's an extra centimeter so that it can be stuck to the other side whenever it's rolled around. So that means that this part would be the circumference of the circle, but it's got an extra 1 centimeter. So if we want to find the area of the label, we're going to do 22.99114858 times 11, and that will give us the area of this rectangle. So the area would be equal to 22.99 and so on, multiplied by 11. So let's do it on a calculator, because we've already got that on a calculator display. Well, actually I haven't, need to add 1. Now we're going to times by 11, and we get that's equal to 252.9026 and so on centimeters squared. Now the question didn't ask us to give it to so many decimal places, so I'm just going to give it to 1. So that's 252.9 centimeters squared to 1 decimal place. So 252.9 centimeters squared to 1 decimal place. And that's it. Okay, let's look at our next question. So question number 7 says a cylinder's got a radius of 8 centimeters. And we've got this diagram here of our cylinder with a radius of 8 centimeters and a height of x. And then if we go on down, we're told the surface area of the cylinder is 1,000 centimeters squared. And we've been asked to work out the height of the cylinder x. Okay, so we know the total surface area of the cylinder, 1,200 centimeters squared. So what I'm going to do is I'm going to find the area of the circle at the top and the area of the circle beneath, because we know the radius of each of those circles, so we can work out the area of each of those circles and then take that away from 1,200, and then what's left would be the area of this curved face. Then, once we know the area of the curved face, we can then form an equation and solve it to find x, the height of the cylinder. So let's do that. So let's find the area of each of the circles. So the area of a circle is equal to pi r squared. So we're going to do pi times the radius, which is 8 squared. And pi times 8 squared would be 64 pi. So that means the circle on the top has got an area of 64 pi, and the circle at the bottom has an area of 64 pi. So 64 pi, also as a decimal number, is equal to 201.0619298 centimeters squared. So that's the area of each of the circles. So if we times that by 2, that'll give us the area of both circles. So that's equal to 128 pi, or 402.1238597 centimeters squared, or in terms of pi, that would be 128 pi centimeters squared. So that's the area for the two circles. So if we take that away from the surface area of the cylinder, what's left will be the area of that curved face. So let's do that. So let's do 1200 take away 402.1238 and so on, and that's equal to 797.8761403 centimeters squared. So that's the area of this curved face. So that's fantastic. We now know the area of this face. I'm just going to actually write it in here, 797.8761403 centimeters squared. Okay, now to get the area of this face, what we would normally do is get the circumference of the circle and then times it by the height of the cylinder. So if we get the circumference of the circle, we can divide the area by the circumference of the circle to get what x is, the height of the cylinder. So let's do that. So the circumference of the circle is equal to pi times the diameter. The diameter of the circle will be 16 because we get 8 plus 8, so the diameter would be 16, so the whole way across would be 16 centimeters. So we're going to do pi times 16, and that's equal to 16 pi, or as a decimal number, 50.265482446. So that's the circumference of the circle. Now normally what we do is we take that circumference and times it by the height of the cylinder to get the area of that curved face. So if we take the area of the curved face, the 797.876 and so on, and divide that by 16 pi or 50.265 and so on, the circumference of the circle, what we get will be the height of the cylinder. So whenever we do 797.8761403 and divide that by 50.265482446, we get an answer of 15.8732 and so on centimeters. So that's the height of the cylinder, 15.8732 and so on centimeters. And I'm just going to round that to two decimal places. So to two decimal places, that'll be 15.87 centimeters to two decimal places. And that's it. Okay, let's look at our next question. Okay, question number 8. Question number 8. Okay, so this time we've got a cylinder. The height of the cylinder this time is 9 centimeters, and we've got the radius of the cylinder's x, and we've been asked to work out the radius of the cylinder. But we are told the surface area of the cylinder is 180 pi centimeters squared. Now it's also a non-calculator question, so I'm just putting down my calculator. Okay, so what I'm going to do here is I'm going to find an expression for the surface area of the cylinder. So I'm going to find an expression for the area of the circle on the top, an expression for the area of the circle beneath, which will be the same as the top, and then an expression for the area of that curved face. Okay, so let's start off with the circle at the top. So the circle on the top, the radius is x, so we would do pi times x squared. So that'll be the area of the circle on the top, or pi x squared. So that's the area of the circle on the top, pi x squared. The area of the circle beneath will be the same, so I'm just going to write this down. So it would be the surface area would be pi x squared plus pi x squared plus, and then we've got the curved face. Okay, so we found the area of the circle on the top and the area of the circle beneath in terms of x, and then we want to find the area of that curved face. So the area of the curved face will be the circumference of the circle times by the height of the cylinder. So the circumference of the circle. So the circumference is pi times diameter, so that's pi times the diameter. The radius of the circle is x, so the diameter of the circle will be 2x, because it's x and another x, that'll be 2x. So we're going to do pi times 2x, because if the radius is x, the diameter would be 2x. And pi times 2x would be equal to 2 pi x. Just put them in order where we put the numbers at the front, like 2 at the front, then our pi, and then our x at the end. So that's the circumference of the circle. We now just need to times that by 9 to get the expression for the area of that curved face. So we're going to do 2 pi x times 9. And when we times that by 9, we get an answer of 18 pi x. So that's fantastic. We now know an expression for the area of that curved face, 18 pi x. So this is great. We now know that the surface area of the cylinder is equal to pi x squared plus pi x squared. Well, that's going to be 2 pi x squared. Let's write that down. 2 pi x squared plus 18 pi x. So that's our expression for the surface area of the cylinder. But we know the surface area of the cylinder is equal to 180 pi. So let's put this equal to 180 pi. So 2 pi x squared plus 18 pi x is equal to 180 pi. Okay, so let's solve this equation. Now, the first thing I notice about this equation is that we've got a pi, and a pi, so we can divide everything through by pi. So if we divide everything by pi, we get 2x squared plus 18x is equal to 180. Okay, great. Now, everything's divisible by 2 here, so let's half everything. So we'd get x squared plus 9x equals 90, dividing everything by 2. Now, this is a quadratic we want to solve, so let's bring everything over to one side. So we've got x squared plus 9x minus 90 equals 0. So just taking away 90 from both sides. Okay, this is great. Now we can factorize. So let's put our brackets in. Bracket, 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 bracket equals 0. Because when you've got a quadratic equaling 0, if you factorize it, if you can't factorize it, it's great because it means you can find your solutions. We've got x squared. So in the front of both brackets, we're going to put an x and an x. And now we're looking for two numbers that times together to be minus 90 and add together to be 9. Whenever we think of two numbers that times together to be minus 90, one of them is going to be positive and one's going to be negative. And when we times them together, so for instance, it could be minus 9 and 10. But if we add them together, we get that's equal to 1. But we want to get 9, so I'm thinking perhaps minus 6 and 15. Because minus 6 times 15 is minus 90, and minus 6 plus 15 is equal to 9. So that means it'll be x minus 6 and x plus 15. So that's fantastic. So we now know that either, if we look at these brackets, if we've got x minus 6, we want that to equal 0, so that means that x would be equal to 6. Or, in terms of this bracket, x would be equal to minus 15. So there are two solutions, either x equals 6 or x equals minus 15. Now, x can't be equal to minus 15 because x is the radius of the cylinder, so that solution wouldn't work. So it means that x equals 6, and that's it. X is equal to 6. And that's it. So in terms of this question, we were given the surface area of the cylinder was 180 pi. So what we done was we found an expression for the surface area of the cylinder, and we got that to be 2 pi x squared plus 18 pi x. We then put them equal to each other and solve that equation. If you need any extra help on factorizing quadratics, if you go to Corbettmaths, and I think it's about video number 115, 16, 17, 18, something like that, 118, 117, 116. There's some videos there on factorizing quadratics, and if you have a look at those, they'll be useful for you as well. And that's it. So the radius of the cylinder is 6 centimeters, and that's it. Okay, let's look at our next question, question number 9. Okay, so question number 9. Question number 9, we've got the cylinder. The height of the cylinder is h, and the radius of the cylinder is 5 centimeters. And we're told that the surface area of the cylinder is 170 pi centimeters squared. And we've been asked to find the height of the cylinder, h. Okay, so what I'm going to do in this question is, it's a non-calculator question, so I'll put my calculator down. I'm going to find the area of the circle at the bottom and the area of the circle on the top. I'll add those two together and then take it away from 170 pi. That'll leave us with the curved surface. That'll leave us with the area of the curved surface. And then we'll then be able to work out what h is, because if we know its area, we can then find an expression for its area in terms of h and then find out what h is. Okay, so let's find the area of the circle at the bottom. So it's a circle. The radius is 5, so we're going to do pi times 5 squared. And 5 squared is 25, so the area of the circle at the bottom will be 25 pi centimeters squared. The circle on the top will also have an area of 25 pi centimeters squared. So if we add them together, that means the area of this circle and this circle altogether will be 50 pi centimeters squared. So that's fantastic. So now we know the area of the two circles. If we take them away from 170 pi, what's left to be the area of this curved face here? So we'll do 170 pi, take away 50 pi, and that's equal to 120 pi centimeters squared. So that's the area of this curved face here, 120 pi centimeters squared. So that's fantastic. We've now got the area of this curved face. Let's find an expression for its area. So to find the area of this curved face, what we normally would do is get the circumference of the circle. So we get the circumference of the circle, and then we times it by h. So the circumference of the circle is pi times diameter. So that's going to be pi times the diameter of the circle, which is 10, because if the radius is 5, the diameter is 10. So that means the circumference of the circle is 10 pi. So we now know the circumference of the circle is 10 pi. Normally we would times that by the height, and we don't know the height, but if we knew the height, we would times it by h, and then that would give us its area. So we know that 10 pi, the circumference, multiplied by the height, which is h, is equal to 120 pi, because we worked that out, 120 pi. So this is great. What would we times 10 pi by to get 120 pi? Well, h has to be 12, so h is equal to 12. And that's it, because 12 times 10 pi is 120 pi. So that means the height of the cylinder is 12 centimeters. 12 centimeters, and that's it. Okay, let's have a look at our next question, question number 10. So question number 10 says, on a farm there's a grain silo. So there's a grain silo. We're told the silo is cylindrical with a tile roof. So there's a tile roof. The silo has a diameter of 8 meters and a height of 6 meters. And the farmer wants to paint the curved surface of the silo, and each can of paint will cover 20 meters squared, or 20 square meters. And the paint costs £11.75 per can. And the question is, how much will it cost the farmer to paint the silo? Okay, so what we want to do here is we want to find the area of the curved surface of the silo. So that's going to be, because we've got the silo, it's standing upright, and obviously it's got some sort of roof, some sort of tiled roof, but we want to find the area of that curved face there, that curved face. So to find the area of this curved face, what we would do is we'd get the circumference of the circle and times by the height of the cylinder. So here we're going to get the circumference of the circle. So the circumference equals pi times the diameter. The diameter of the circle is 8. It's got a diameter of 8, so we're going to do pi times 8 meters. And that's equal to 8 pi, or as a decimal number, that's equal to 25.1327 and so on meters. So that's the circumference of the circle. Now to get the area of that curved face, we would then times it by the height of the cylinder. And the height of the cylinder was 6 meters. So we're going to take the 25.13274,123 and we're going to times that by 6. So when we times that by 6, we get an answer of 48 pi. Or, in terms of a decimal number, that's 150.79644474 meters squared, or square meters. So that's the area of the curved surface of the silo. Now, each can of paint covers 20 square meters. So in terms of how many cans we'd need, if we divide the total area by 20, that'll tell us how many cans we need. Well, if it tells us how many exact cans we need, we can't actually buy that number, but we'll come back to that in a minute. So if we take the 150.7964 and so on, and divide that by 20, how much the coverage of one can of paint, that's equal to, we would need exactly 7.53982 and so on cans of paint. But the farmer's obviously going to need to go in and buy the paint, and it costs £11.75 per can. So the farmer's going to need to buy 8 cans of paint, because the farmer can't buy 7.539 and so on. The farmer's going to have to buy 8 cans of paint. So let's take the cost of one can of paint, which is £11.75, and times that by 8, because the farmer will need to buy 8 cans of paint. So if we do 8 times £11.75, that's equal to £94. So it's going to cost the farmer £94 for the paint, and that's it. Okay, let's have a look at our next question, question number 11. So question number 11 says, shown below is a semi-cylinder. So we've got the semi-cylinder. So it's a cylinder that's been chopped in half, so chopped down vertically there. And we've got the radius of the base of the semi-cylinder is equal to 7.5 centimeters. That's the distance from here to the edge. And it'd be the same distance from here to here, and so on. And we're told that the height of the semi-cylinder is equal to 19 centimeters. And we've been asked to work out the surface area. Okay, so if we want to find the surface area, we need to get the area of the 4 faces. We've got the semicircle on the top, the semicircle beneath, the rectangle here at the front, and then we've got the curved face at the back, so that curved face. So that'll be, if you consider the cylinder, the whole cylinder to begin with, that'll be half of the curved face going around the outside of the cylinder. So it's half of that. Okay, so let's find the area of each of them to begin with. So let's start off with the semicircle on the top. So to find the area of the semicircle on the top, what I'm going to do is I'm going to do pi r squared for the whole circle and then divide by 2. So the area of the whole circle will be pi times the radius, which is 7.5 squared. And if we do pi times 7.5 squared, we get an answer of 176.71458868 centimeters squared. Now that area is the whole circle. We only want the area of the semicircle. Now in theory, you could just use this area because this semicircle and the semicircle beneath, when you add those two circles together, they'll have this area. But what I'm going to do is I'm going to divide by 2 just to show you that that will be the area of the semicircle. So 176.7145 and so on divided by 2 would be equal to 88.35729.338 centimeters squared. So that's the area of the semicircle on the top. So let's write that down. So the area of the semicircle is equal to 88.35729.338 centimeters squared. And that's the top. And the area of the bottom will be the same, so that's another 88.357293338 centimeters squared. Now, as I said, you could have just actually used the area of the whole circle because we knew we were going to half it and then add it to itself. Okay, so that's the area of two faces. Okay, now let's do the rectangle at the front. That's quite straightforward. It's a rectangle. In terms of this rectangle, we've got a height of 19 centimeters and a width would be, well, 7.5 plus another 7.5 would be equal to 15 centimeters. So that means if we do 19 times 15, that's the area of that rectangle. So 19 times 15 is equal to 285 centimeters squared. So that's the area of that rectangle at the front of the shape, so 285 centimeters squared. Okay, so we've got the area of three of the faces. Now we just need to get the area of that curved face at the back, which would be half of the whole curved face of the cylinder. So what we're going to do is we're going to pretend it's a whole cylinder. So we're going to consider the whole cylinder and we'll get the circumference of the whole cylinder and times it by 19, and that'll give us the area of the whole curved face of the cylinder, and then we'll divide by 2 and that'll give you the area of that curved face, half of it. Okay, so let's consider that whole cylinder and let's find the circumference of the circle at the top of that cylinder. So the circumference of a circle is pi times diameter, and the diameter of the whole cylinder would be, if it's a whole cylinder, the diameter would be 15 centimeters. So we're going to do pi times 15, and that's equal to 15 pi. So 15 pi, you could write it as a decimal number if you wanted to. So that's the circumference of the whole circle at the top of the cylinder. Then we're going to times it by 19. So we're going to do 15 pi multiply by 19 and see what we get. So 15 pi times by 19 is equal to 285 pi. Or as a decimal number, 895.353 and so on centimeters squared. So that would be the area of the curved face of the whole cylinder. Now this is a semi-cylinder, so we're going to divide that by 2, and that'll give us the area of that curved face at the back of this semi-cylinder. So we're going to do 895.353 and so on divided by 2. And let's see what we get. So divide by 2, and that's equal to 447.6769 and so on centimeters squared. So that's fantastic. We've now got the area of all four faces. So let's write that one down. 447.6769531 centimeters squared. And then to find the total surface area of that semi-cylinder, we just add them up and see what we get. And that's equal to 909.3915399 centimeters squared. And that's it. So that's the total surface area of that semi-cylinder. And so what we done was we found the area of the two semicircles, the area of the semicircle on the top and the area of the semicircle beneath by considering the whole circle and then dividing by 2. We found the area of the rectangle at the front of the semi-cylinder, and then we found the curved face at the back by considering the whole cylinder, finding the area of that curved face for the whole cylinder and then dividing it by 2. And that's it. So the answer would be 909.39 to 2 decimal places. And that's it. Okay, let's look at our next question. Question number 12. So question number 12 says that Fleur is creating a piece of equipment for soft play. So this is a piece of equipment for soft play. Okay, and then we're told she starts with a cylindrical piece of foam. So she's got this piece of foam that's a cylinder, and it's got a diameter of 50 centimeters and a length of 1.4 meters. And then we're told from the center of the circle, Fleur removes a cylinder of diameter 30 centimeters. So she's got the cylinder and then she takes the cylinder away from the middle. So she's kind of taken the core of the cylinder away. And then finally she removes the top half of the foam. So she then cuts it in half. So she's got this whole cylinder, she takes the cylinder away from the middle and then she chops the top off. So then she's left with this U shape. And then we're told the diagram shows the piece of equipment. So we've got this piece of equipment. And then if we go down, we're told to work out the surface area of the piece of equipment. So we want to find the surface area of this piece of equipment. Okay, so let's consider the faces. We've got, and I'm going to label them, we've got A, which is this rectangle here. We've got B, which is this rectangle here. We've got C, which would be this curved face in the middle of the piece of equipment. Then we've got D, which is this part here, this flat face of the cylinder here. And then we've got E, which would be the same on the back. So E would be the same on the back, so it's the same as D. And then we've got F, which would be that curved face at the bottom of the piece of equipment. So going the whole way around the bottom of it. It's from this side all the way around to that side, so it'll be the bit at the bottom. And we've been asked to work out the total surface area of the piece of equipment. So we need to find the area of A, B, C, D, E, and F, and then add them all up. Okay, so let's start off with A. So A is a rectangle. In terms of the rectangle A, it's got a length of 1.4 meters. Now let's go down. The answer is in centimeters squared, so we need to give our answer in centimeters squared here. So let's change the 1.4 meters into 140 centimeters. So let's find the area of A. So A is a rectangle, it's got a length of 140 centimeters, and we want to find this length here. Now the whole diameter of the cylinder to begin with was 50 centimeters, and this bit's been cut away, which has a diameter of 30 centimeters, so that leaves 20 for this length and this length. And if you divide that by 2, you'll get 10 centimeters there and 10 centimeters there. So that means to find the area of A, we're going to do 140 centimeters multiplied by 10 centimeters. So 140 multiplied by 10 is equal to 1,400 centimeters squared. And that's the area of A. And B, if we look at it, is actually identical to A. It's got the same length and the same width. So B would also have an area of 1,400 centimeters squared. So we've got the areas of A and B. Okay, so in terms of C, let's consider that whole cylinder that was cut away. So that cylinder with a diameter of 30 centimeters. So the circumference of that whole circle at the end of it would be pi times diameter. So pi times 30, which is equal to 30 pi. You could write it as a decimal number if you wanted to. And then we're going to times that by the length of the cylinder. And if we times that by the length of the cylinder, so if we take our 30 pi, and then we'll times by 140. And that'll give us the area of that whole curved face going around on the outside of a cylinder with a diameter of 30 centimeters. Now obviously C is just going to be half of that, but we just need to find the area of the whole outside first of all. So we're going to do 30 pi, so 30 pi multiplied by 140 is equal to 4,200 pi, so 4,200 pi, and then we're going to divide that by 2. So we're going to take our 4,200 pi, and then we're going to divide by 2, and that's equal to 2,100 pi. So that is the area of C, centimeters squared, or as a decimal number, it would be equal to 6,597.344573 centimeters squared. But I'm just going to leave it in terms of pi at the minute. Okay, so we found the area of A, that rectangle, which is 1,400 centimeters. We found the area of B, which is 1,400 centimeters. And we found the area of C, which is equal to 6,597.3445 and so on centimeters squared, or 2,100 pi centimeters squared. And to find the area of that curved face C, what we done was we considered the whole cylinder that was cut away with a diameter of 30 centimeters. We done pi times 30 to get the circumference of the circle at the end of that cylinder. We then times by 140 to find the area of the outside of that cylinder that was cut away, and then we divided it by 2, and that's given us the area of C. Okay, now let's find the area of D. So in terms of D, what we're going to do is we're going to find the area of the whole circle at the end of the original cylinder. So that whole original cylinder, the piece of foam to begin with, it had a diameter of 50, and we're going to find the area of that whole circle. And then what we're going to do is we're going to find the area of the circle at the end of that shape that was removed. So we'll consider that cylinder that was removed with a diameter of 30 centimeters, and we'll find the area of that circle. And then we'll take them away, and that'll tell us the area of this ring here going around the outside of that cylinder. Then it was cut in half, so then we'll divide by 2, and that'll tell us the area of D. Okay, so let's consider this whole circle to begin with. I'm just going to do a little sketch of it, that whole circle there to begin with. So let's do pi times, now it's pi r squared. For that whole circle, it has a diameter of 50, so that means the radius will be 25. So we're going to do pi times 25 squared to begin with. And that's equal to 625 pi centimeters squared. You could write it as a decimal as 1,963 and so on centimeters squared if you wanted to, but I'm just going to work in terms of pi here. So that means the area of that whole circle would be 625 pi centimeters squared. Now, we know a smaller circle has been removed at the end of the shape. So in terms of that cylinder that was removed from the middle, in terms of the end of the shape, that means that a circle with a diameter of 30 centimeters has been removed. So let's do pi times, and then the radius would be 15, so 15 squared. So let's find the area of that circle. And pi times 15 squared is 225 pi centimeters squared. Or as a decimal number, that would be 706.8 and so on centimeters squared. So now we're left with this shape here going around the outside, this ring at the end of the shape. So if we take them away, if we do 625 pi, take away 225 pi, what's left to be the area of that ring? So that shape there. So that would be equal to 400 pi centimeters squared. Now that's the whole way around. Remember the shape was cut in half. So we're now going to divide by 2. So let's take the 400 pi and divide it by 2, and that's equal to 200 pi centimeters squared. Or as a decimal number, 628.318 and so on centimeters squared. So that is the area of D. So D, this area here, is equal to 200 pi. And that's it. And that means also E has an area of 200 pi as well. So that's D and E. So they're each 200 pi centimeters squared. Actually, I'm just going to write a bit of a list here, okay? So the area of A was 1,400 centimeters squared. The area of B was 1,400 centimeters squared. The area of C, that curved face in the middle going the whole way along, would be 2,100 pi centimeters squared. We have got We have got D, which was equal to 200 pi centimeters squared, and we've got E's 200 pi centimeters squared. Okay, now let's consider F. So F is that curved face at the bottom of the shape, so it's quite a big face, and we want to find the area of F. So to find the area of F, I'm going to consider that original cylinder. So that original cylinder, so we've got that original cylinder, really bad sketch out, that original cylinder that goes down, that original piece of foam that she had. And if we find the area of that curved face going around the outside of that cylinder, by doing the circumference of the circle times the length of the cylinder, that'll tell us the area of the whole curved face going around the outside of the cylinder. And then we'll just divide it by 2, and then that'll be the area of F. So let's do that. So the circumference of the whole circle, well, it'll be pi times 50, because the diameter is 50. So we're going to do pi times 50, and that'll be the circumference of the whole circle, and then we'll times by 140. So let's do that. So F, we're going to do pi times 50. That'll give us the circumference of the whole circle at the front of that cylinder, that original cylinder. So that's 50 pi. And then we're going to take that 50 pi, the circumference of the circle, and we're going to times it by the length of the cylinder. And that'll tell us the area of the curved face of the cylinder. So 50 pi times by 140 is equal to 7,000 pi. So if we had the whole cylinder, that would be the area of the curved face going around the outside of that whole cylinder. Then we're going to divide by 2 because it was cut in half. So 7,000 pi divided by 2 is equal to 3,500 pi. Or as a decimal number, that's equal to 10,955.57 and so on centimeters squared. Okay, so that's fantastic. We've now got the area of F. The area of F is 3,500 pi centimeters squared. So now, to find the surface area of the piece of equipment, we just need to add these together. Now I'm going to do this twice. I'm going to do it once where we've got the values in terms of pi here for these 4 areas, and then I'll do it again where these values are in decimal form, just so that if you've got those values, you know which ones are right for you. So let's add these up and see what we get. So if we add together 1,400, 1,400, 2,100 pi, 200 pi, 200 pi, and 3,500 pi, we get an answer of 21,649.55592 centimeters squared. So that'll be the total surface area of that piece of equipment, and that's it. Now I did say that if you worked in terms of decimal numbers, I would do the addition again. So you would have had 1,400, 1,400. Here you would have had 6,597.344 and so on centimeters squared for the area of C, that curved face in the middle of the piece of equipment. Then you would have had 628.3185 and so on. You would have had another 628.3185 and so on. And then finally, in terms of F, the area of that big face at the bottom of the shape, you would have had 10,995.574 and so on. And then you'd add all those up and your answer would be 21,649.55592 centimeters squared. And that's it. So that's the surface area of that piece of equipment. 21,649.56 to 2 decimal places. And that's it. Okay, let's look at our next question. Question number 13 says the cylinder above has a surface area of 400 pi centimeters squared, and we've been asked to calculate x. So what I'm going to do is I'm going to form an algebraic expression for the surface area of the cylinder that we've been given. Then what I'm going to do is I'm going to put it equal to 400 pi, and then hopefully we can solve that equation and find out what x is. So let's do that. So to find the surface area of the cylinder, we need to get the area of the circle on the top, the area of the circle at the base, and the area of the curved face on the outside of the cylinder. So the area of the circle on the top, it'll be pi r squared, so pi times the radius. Now the diameter of the whole cylinder is 2x, that means the radius would just be x. So it'd be pi times x squared, and that means it'd be pi x squared. So that's the area of the top, so the top is pi x squared. The base would also be pi x squared. And then we need to find the area of the curved face going around the outside of that cylinder. So what we would do is we would get the circumference of the circle, because remember, if you were to cut that vertically and roll it out flat, you would have a rectangle, and the circumference of that circle would be the length of the rectangle. So we're going to get the circumference of the circle by doing pi times diameter, and then we'll times it by x, the height of the cylinder, and that'll give you the area of that curved face. So we're going to do the circumference of the circle, which is pi times the diameter, which is 2x. So that'd be equal to 2 pi x, just putting them together and putting them in order of the numbers, then pi and then x. So that'll be the circumference of the whole circle. And then we're going to times by x, which is the height of the cylinder. So that means the area of that curved face would be equal to 2 pi x, the circumference of the circle, times x, the height of the cylinder, which would be equal to 2 pi and then x squared. So that means the area of that curved face would be 2 pi x squared. So let's write that down. So the area of the curved face is 2 pi x squared. And then if we add them all together, that'll be our expression for the total surface area of that cylinder. So pi x squared plus 2 pi x squared would be 4 pi x squared. So altogether we'd have 4 pi x squared. Now that's fantastic because we've been given the total surface area in the question. So we can make an equation. 4 pi x squared would be equal to 400 pi. And then we can just solve this equation. So if I wanted to solve this equation, the first thing I would do is divide by pi. So divide both sides of the equation by pi to get 4x squared equals 400. Then I would divide both sides of the equation by 4 to get the x squared equals 100. Okay, now if we have a look at this equation, x squared equals 100. Strictly speaking, this equation has two solutions. If we square root 100, it'd be 10. So 10 is one solution. Or it could also be negative 10 because negative 10 squared is equal to 100. But in this situation, it wouldn't make sense to have a negative height. You can't have a height of negative 10 centimeters. So that means that x would be equal to 10. And that's it. We've calculated x. X is equal to 10 centimeters. And that's it. Okay, let's look at our last question. Okay, question number 14. So question number 14 says, a mobile pizza van sells slices of pizza. So we've got this mobile pizza van, so it's a van that drives around and sells slices of pizza. And the box they use is shown below. So they've got these special boxes. And we're told that the box has got a height of 5 centimeters. And the cross-section of the box is a sector. So it's a sector the whole way through this box. And it's got a radius of 12 centimeters and an angle of 120 degrees. And we've been asked to find the surface area of this box. So we want to find the surface area of this box. So let's consider the faces and let's label them. We'd have A, that rectangle there. We'd have B, that rectangle there. We'd have C, which is this sector at the top of the box. We'd have D, which is the same sector at the base of the box. And then we would have E, which is that curved face that goes around the outside, the back of the box there. So it's that curved face that goes around the back of the box. Okay, so let's consider A to begin with. A, the area of A will be 5 times 12. So 5 times 12, it's a rectangle. So that'll be 60 centimeters squared. So that's fantastic. And I'm just going to write it on a list here because we're going to be adding them all up. So 60 centimeters squared. That is A. Okay, B, so let's go back up. B is identical to A because obviously if this is a sector, the cross section of this box is a sector. That means that this is the radius and that's the radius. So that means that that will be 12 and the height is still 5 and 12 times 5 is 60 as well. So B would have an area of 60 centimeters squared as well. So let's write that down. B, 60 centimeters squared. Okay, now let's find the area of C. Okay, now C. So we want to find the area of the sector at the top of the box. Now there's a formula for the area of a sector, which is beta over 360 times by pi times by the radius squared. And I like that formula and I use it a lot whenever I'm finding the area of sectors. So what I would do is I would do beta, which is the angle, which is 120 degrees over 360 because that's the fraction of the whole circle. If it was a whole circle, what fraction of the circle would it be? And this is 120 360ths, or a third if you cancel it down, times by pi times by the radius of the whole circle. If it was a whole circle, what would the radius be? Well, that would be 12 centimeters, 12 squared. And if you type this into your calculator, you get the area of that sector. So let's do that. And if you do that, you get an answer of 48 pi, or as a decimal number, 150.7964 and so on centimeters squared. So that's the area of C, that sector. So that's one approach, is to use the formula beta, which is the angle of the sector, over 360 times by pi times by the radius squared, the radius of the whole circle, squared. So that's one way you can find the area of that sector. Another way is actually just to consider the whole circle. Some people don't actually use the formula, they just consider the whole circle. So they do pi r squared, so pi times 12 squared. And then they know that 120 is a third of a whole circle, so they get the area of the whole circle and then just divide it by 3, and that's fine as well. Alternatively, what some students do is they actually get the area of the whole circle, so they do pi r squared to get the area of the whole circle. They divide it by 360 and then times by 120 to get the area of that sector, and that would work as well. So all those approaches would find the area of that sector C, which is 150.7964 and so on centimeters squared. So let's write on our list 150.79644474 centimeters squared. And D would be the same. So D has the same area because obviously that would be the base of the box. Okay, so that's the area of 5 faces. We've just got one left, which is E. So E is that curved face going around the back of the box. Well, there's a few approaches we could use, but the approach that I'm going to use is I'm going to consider if I laid it out flat. If I laid out E flat, you'd have a rectangle. And the width for the rectangle would be this distance here, which is 5 centimeters. And in terms of the length of the rectangle, that would be this arc length. If you had this curved face, if you laid it out flat, the length of that rectangle would be that arc length. And then we just need to do the arc length times 5. So I want to find this distance here. And to find this distance here, what I could do is I could get the circumference of the whole circle and then just divide it by 3 because that's a third of a circle, and that's fine. Or I could use the formula. Okay, so to find the arc length, what we could do is we could use the formula, which is β over 360 times by pi times by the diameter. In other words, the fraction of the circle times the circumference. So we'd have 120 over 360 times by pi times by the diameter of the whole circle. So if this was a whole circle at the top, what would the diameter be? Well, the radius is 12, so the diameter of the whole circle would be 24. So if we were trying to find if that was a whole circle, what would the diameter be? And the diameter would be 24. So we'd do pi times 24. And that's what we would do if we were trying to find the circumference of the whole circle. We would do pi times 24. So this arc length is equal to 120 over 360 times pi times 24. And when we do that in a calculator, we get an answer of 8 pi or 25.1327 and so on centimeters. So that is the length of that arc from here around to here. That distance there would be 25.13274.123 centimeters. So that's the length of that arc. And if we laid out E flat, it would be a rectangle, and we would do that arc length times 5 to get its area. So let's just times it by 5 now. So let's take that 25.1327 and so on, and times that by 5 and see what we get. So that's equal to 40 pi or 125.6637061 centimeters squared. And that's the area of that face E. And that's it. Now, I just want to mention here that some people may have got this arc length by just doing the circumference of the circle, so doing pi times 24, and then just dividing it by 3 because that's a third of the circle. So rather than using this formula, they just get the circumference of the whole circle and then divide it by 3 and then times that by 5. Okay, so that's fantastic. We've now got the area of E. So E, the area of E, that curve facing the back of the box would be 125.6637061 centimeters squared. And then let's just add these all up, and that'll be the surface area of the box. So let's do that. And when we add those all up, we get an answer of 547.2566009 centimeters squared. And I'm just going to round this. I'm going to round it to 3 decimal places. So that'll be 547.257 centimeters squared to 3 decimal places. And that's it. So that's the surface area of that box. And that's it. So these have been the video solutions to the Corbettmaths practice questions on the surface area of a cylinder. I really hope you found this video useful. If you need any extra help on the surface area of a cylinder, if you go to Corbettmaths and go to the videos and worksheets section and scroll down to video number 315, there's a dedicated video tutorial there on the surface area of a cylinder. Alternatively, you can scan this QR code. But again, I really hope you found this video useful. If you have found it useful, please like it and please subscribe to my YouTube channel. Also, if you know anyone who might find the Corbettmaths website useful, whether it's a friend or a teacher, please share the Corbettmaths website with them as well. Thank you. Cheers. Bye.